We are now recording. Let's get the slideshow set up for the current slide, and we'll go from there. Okay. Any questions on what we've done so far? Okay. Just a little bit of reminder. Several people have turned in their quizzes. A few people have. Here's the deal on the quizzes now. I can't return the quizzes until I get them all in. Otherwise, the correct answers are floating around out there. And not that you would mean to share it with somebody. Someone might see it and then cheapen your grade. I don't want that to happen. Now, anytime you want to see what you did on your quiz, you can see me, before class, after class, and I'll answer any questions you may have. Can't do it on the board while there's still quizzes out. But as soon as I get all the quizzes in, I want to get them back to you. And I'd rather that happen before the test. So please, folks, try to get the quizzes in. I'm probably preaching to the choir here because you're the ones who are most likely to have them in. The people who are not here are most likely the ones who haven't. Yes? It'll be when we finish 1.9, and we're in 1.8 right now. So coming up relatively soon. Okay. So try to get the quizzes in sooner rather than later. And papers are due in any time. I think I've already gotten at least one from this course and some from other classes as well. All right. Any questions? Here's where we left off last time. We're now doing combinations of functions, and we will, in the second part of this, do compositions of functions. The first combinations of functions we're going to deal with are the arithmetic combinations. Adding functions, subtracting functions, multiplying functions, and dividing functions. So here's our two functions. F of x is 2x plus 1. G of x is x squared plus 2x minus 1. And it says, find f plus g of x. Now, for many, you might find it easy just to remember the formula or the thing that we did last time. I guess it's called it wasn't called definition. It's just the block that did it. What do we mean by f plus g of x? Let me see. I've got it. Okay. Okay. F plus g of x is f of x plus g of x. That's the definition of the sum function. Right. You add those two together, so that would be 2x plus 1. That's the f, plus x squared plus 2x minus 1. There is a sum of those two functions. Now, like you say, rearrange, combine like terms, what do you get? X squared plus 4x, done. Okay? Now, the next thing it says is evaluate this sum when x is equal to 3. So this is what we call f plus g of x. Okay? So what do we do? Okay, plug it in, plug it in. F plus g of 3 would be 9 plus 12 equal 21. Okay, pretty straightforward. Correct. Hopefully it's exactly like you would expect it to be. I want to show you something else. Okay? What if we plug the 3 into F and then the 3 into G? Should get the same thing, right? What's F of 3? 7. What's G of 3? You don't have to add it all. You can call out the... Say again? Okay, 9 plus 6 minus 1, sure enough, is 14. And what's 7 plus 14? 21. So, you can check it that way if you'd like. Sum functions, pretty simple. Now, one thing we didn't mention, mostly because it was almost, as mathematicians say, intuitively obvious, these are both polynomial functions, and polynomial functions have domains, all real numbers. So you didn't have to worry about the domain anywhere. Some functions you do, polynomials you don't, so I didn't even think to mention it. All right, let's clear what we did. And let's see, anyone need this up a little bit longer? Huh? Yes? Okay. What we'll do is clear this and see how they present it. I think it's almost identical. I can't think of many ways you can change this, but we'll see what they did. If you got questions, good time to ask too. I'm sorry? Okay. So let's clear the screen and let's see how they proceed. Well, the sum function, just like we said, f plus g of x is f of x plus g of x, which is f of x, 2x plus 1, plus g of x, which is x squared plus 2x minus 1. Now, remember the things on parentheses. I think it's a good idea for you to visualize this is your f function, that's your g function. But in reality, this first set of parentheses you're going to just get rid of anyway because there's nothing in front of it. So it's not really doing anything except when you see it. When there's a plus in front of parentheses, you can remove those too because it doesn't do a thing to it. So those are there just for your comfort or security or whatever, but you can remove those or not. Just go on and add like terms, combine like terms, and they got the same thing we did. Now the second part, when x is equal to 3, f plus g of 3 is 3 squared plus 4 times 3, plugging in, and that gives you 9 plus 12 is 21. Good deal. Any questions? Pretty straightforward, especially if you don't have to worry with domains. All right, they skip number 2, okay, which is a difference function. And let's go back to, I wish we could go back to what I had done before. Well, let's do this anyway. Example 2 was when f of x is this same function and g of x is this same function. It says now find f minus g of x. Okay, and what would that be? F of x minus g of x, which would be 2x plus 1 minus, now in this case, since that's not a plus sign in front of it, I suggest you put those parentheses in. And what would that be? X squared plus 2x minus 1. Now, before we combine like terms, we have to clear the parentheses. That's how they used to say it. Distribute the minus sign across the parentheses, however you want to say it. What would this be? 2x plus 1 minus x squared minus 2x plus 1. Very good. Now when you combine these like terms, what do you get? Negative x squared plus 2. Now your 2x's add to 0. Plus 2x minus 2x, those add to 0. So that gives you x squared minus x squared plus 2. Now you could write that as 2 minus x squared if you don't like leading off with the minus sign. It doesn't really matter. Okay, the second part though says evaluate that difference when x is equal to 2. So we're looking for f minus g of 2. And what would that be? Okay, tell me how you do it. Okay, you do minus and then 2 squared, right, plus 2. All right, now what do you do first? Second? Square the negative 2. And then you square the 2. Please excuse my dear Aunt Sally. You wait and do this at the end. If that negative 2 were in parentheses, yes, you would square it, because parentheses, please, you do first, but you do the exponent before you negate. Please excuse my dear Aunt Sally. E before S, okay? So exponentiate, then subtract, or negate. You see it? Now, if that were negative 2 squared, as in parentheses here, then you do this ties these together and you square that. This one, though, says square just what's in front of it, then you negate what you got. So what would that give you? Say again? That would be a minus 4 plus 2, which is negative 2. You see that? Okay. Let's see how the book did. They don't have it in slide. Yes, they got it right. Good for them. Now, there's checkpoints after every one of these. And those checkpoints have audio-video solutions at larsonprecalculus.com. Great study aid, website support here. This book is the best at doing that of any I've seen. All right. Any questions on that? Yes. Say again? Right. Oh, okay, yeah. The first part says find what the difference function is, and that's what that is. That's f minus g of x. That was the first part. It says then evaluate that at x equal 2, and that's the second part. Yeah. All right, good deal. Any other questions? And most of the time on test, I'll put 2 blanks if I expect 2 answers to make it pretty obvious. Always ask rather than assume. In the Navy, we used to have a phrase about assuming, but we won't go into that. But anyway, some of you have heard it. Huh? Okay. All right, let's go. Example 3. Sorry, I can't talk. Okay. Example 3, they're changing our functions. Okay. In this case, okay, so none of this is appropriate anymore. Let's say f of x is equal to x squared. The good old squaring function, parent function, okay? G of x is equal to x minus 3. Okay, and by the way, all these are still polynomial functions, all real numbers, so you don't have to worry about limitations on domains. What they're looking for now is fg of x. And what is fg of x? Multiply together. F of x times g of x. And that's pretty simple to write down. What would that be? F of x is x squared times g of x is x minus 3. Okay, when you're multiplying, quite often you use parentheses for that. If this was a binomial or a trinomial or anything bigger than a monomial, you would put that in parentheses, that in parentheses. If it had been bigger, you would have foiled it or do whatever you take. This is just a monomial. What would that give you? X cubed minus 3x squared. Perfect. Now, do they have another part to this? Yes. Then evaluate the product when x is equal to 4. Now, I forgot to do that with the subtraction, do it 2 ways, but you could do that. So they're looking for fg of 4. Okay, and what would that be? You can do several steps. Say again. 4 cubed minus 3 times 4 squared. Okay, I'm going to put it like that. Okay. Now, again, it sounds a little bizarre, but you would not think of doing this as 3 4 squared, would you? 3 times 4 squared. No, you do the x squared, the 4 squared, and then multiply by negative 3. That's the reason that the negative 3 wasn't there. You do the 4 squared and then negate it. Same type principle. Okay? What does this give you, by the way? I was blowing off here. 4 cubed is 64, if I could write, minus 48. Very good. And what's that? 16. Very good. How'd they do? Oh, they got it right too. Good for them. All right. Any questions on that? And again, polynomial functions don't have to worry with domains at all. All real numbers for everything. Okay. I thought I erased it. I guess I didn't. Okay, that time I did. Now we're getting, they really pop it to you on this one now. Find f divided by g and g divided by x for the functions f of x, but not these, f of x is equal to the square root of x, and g of x is equal to the square root of 4 minus x squared. Now, you might wonder why he left those blanks in there. These are not polynomial functions. Not all non-polynomial functions have limits, but these do. These have limits in the domain. For your f, what are your limits in that domain? Second? Okay, that's one way to say it. How can you write it in math speak? Symbols. X, if it's not negative, it has to be greater than or equal to 0. Got it. Okay? How about the g? This will take maybe a few steps here. Basically, same thing he did here. If you notice what he did, he took what's under the hat, under the radical in the house here, okay? And that thing has to be greater than or equal to 0. You do the same thing there, but what does that give you? I wish I hadn't made that line so long. Let me reduce that just a little bit, okay? Okay. In fact, I'm going to tighten it up even more. I got sort of expansive there when I was, this is the square root of 4 minus x squared. Okay? Now, what can we say about that? Hit me, hit me. Same thing as before, except now it's an expression under there, not just a single variable. That expression is, what's under the 4 minus x squared. And what can you tell me about it? What do we say about the x? It has to be greater than or equal to 0. Okay. Meaning positive or non-negative is more precise. It's a little more complicated, just a tad. What would you suggest we ought to do to that to simplify it a little bit? What do you notice about this expression? What's that sign there? A minus sign. And what do we call subtraction? The result is the result of addition is a sum. The result of subtraction is a difference. This is a different sum. And what do you notice about these two entities here? 4 is 1 and x squared is 1. Perfect. L7. Squares. This is the difference of two perfect squares, right? And we know what we can do with that. You better be nice. Okay. Second. What's the F word? Factor. Okay. Can we factor that? How would that factor? I feel like a dentist this morning. Okay. What would that factor? A little louder. Okay, I'll give you some help. Okay, how does that factor? Okay, how about let's start with 2. 2 and 2. Okay, back to 098. Okay. Say again?
It's been a long time.
Yeah, a real long time. Okay. You don't remember this, huh? X, yeah, minus x and plus x. the difference of two perfect squares factors as the sum times the difference of their square roots. Y'all knew that, didn't you? Please say yes. Okay? All right. Now, still got a little ways to go. Okay? If that was a not equal to, it would be relatively easy to solve that. However, this is a greater than, a directional inequality. Okay? What we have here is a product of two numbers, right? And how is a product of two numbers always, let's just call it positive, though we're counting 0 too. What two entities do you know when you multiply them together are always positive? Say again? If they have the same sign. Now, this could be two signs, right? Either both positive or both negative. So we have a little bit of manipulation to do here. Either 2 minus x, which you want to do first, positive or negative, I don't care. Positive. Is greater than or equal to 0 and 2 plus x greater than or equal to 0. Or 2 minus x is less than or equal to 0 and 2 plus x is less than or equal to 0. You got two possible cases here, both positive or both negative. The only way you can get that to be positive, greater than or equal to 0. So let's solve both of these and see what we get. What will we do to this one? Solve for x. Okay, what are you suggesting? Add x to both sides. That's a good way to do it. Okay, and what would that give you? That would give you x is less than or equal to 2. Do you see what's happened here? When you moved it over there, if we count this the same, which you should have, 2 is greater than equal to x, which when you flip that, you have to flip the whole thing. X is less than or equal to 2. All right, now I'm going to do something here, which is a little elementary, but I think it's helpful to see. Let's draw our number line here, okay? Here's our entire number line, with that being a 0, 1, 2, 3, 4, 5, 6, 7, 8, negative 1, 2, 3, 4, 5, 6, 7, whatever. Okay, and here's our 2, and this says that, and the equal to, so I'm going to darken in that, and this x would be everything less than or equal to 2, right? All right. Let's go with a new color. Pick your favorite color. Not black. Second, purple. Okay? All right. So let's do the second one here. How do we solve that inequality? This one right here. Solve for x. How do we do that? Okay, subtract 2 from both sides. Is that what I heard? I'm hard of hearing. Okay, that goes to 0, and that gives you x is greater than or equal to negative 2. So let's find that. There was our 0. There was negative 1. Here's negative 2. And if it's greater than or equal to negative 2, you're here, right? All these values. Well, what's in common between those two? From negative 2 to 2. So our domain for this function, when they both are positive, is let me just write it this way. Negative 2 to positive 2. Okay. Now, that's one case, one scenario. Let's do the one at the bottom. You want to leave that black or go to purple or something else? Say again? Fine. Let's leave it purple because that's what my pen is now. So let's solve this one. How do we do that? Add x to both sides. And what does that give you? 2 here That goes to 0. Less than or equal to x. Which another way of saying that is x is greater than or equal to 2. Okay, now what I'm going to do, because I've not managed my board well, is let me erase some of this mess, stuff. Okay. Oops, I lost my one. Okay, I erased a little too much, but I think I can get it all back. Okay, there was 1, there was 2. Okay, how would you express that inequality on the number line? Here is 2, and it can be equal to 2. If x is greater than or equal, where's x? All to the right. So this is now what that one expresses. Now let's go with a different color. Could be black or anything other than purple. What you want? Orange. Okay. Here's orange. Okay. How do I solve this for x? Subtract 2 from both sides of the equation. It's pretty familiar, isn't it? This adds a 0, and does that give you? A little louder. X is less than or equal to negative 2. Well, let's find negative 2. There it is, and it can be equal, so I'm going to color that in. And what is x less than or equal to negative 2? Those are the numbers below that. Now, what do those two have in common? Absolutely nothing. The intersection of those two sets is the empty set. There is nothing in common between those two. Boy, that's sort of looking like LSU. Where's Les Miles? Never mind. We will. Yeah. Okay, I know. Okay. All right. So this does not work. You have to choose both of your x's of these factors being positive, and this is your domain for g of x. Now and forever in this for this problem, that's your domain. You're limited to that. So let's get some of this off the screen. Okay, I don't think we need this anymore. And you don't have to do all that, but boy, you do have to analyze it completely. Okay, I find drawing the number line helps people visualize what's going on. So here we have our two functions, and we haven't even started doing what they told us to. Here's the two functions. Here's the domain of the first function. Here's the domain of the second function. Okay. What we're asked to do here is first find, do y'all want to stay with orange or go to something else? Can you read orange okay? Okay. What they're first asked us for is what f over g of x is. And what's that? What's the definition of that? A little louder. The quotient function is the quotient of the functions. The quotient of it's f of g, f of x divided by g of x. Once you get to this part, it's almost really easy, okay? You just plug in, get out of there. Okay, plug in what f of x is. The square root of x over, plug in what g of x is, the square root of 4 minus x squared. Right? Now you're doing an operation with these two functions. What do you do with the domains? They have to be the domains they have in common. The domain of this one is all x is greater than or equal to maybe I erased my number line too soon. Y'all want this in orange, or should I go to something else? Okay, we'll do it here. So our F function was, here's our 0, 1, 2, 3, 4, 5, 6, 7, negative 1, 2, 3, 4, 5, 6, okay? It was F was greater than or equal to 0. There was our domain of F. What was our domain of G? I want to go back to the purple. Domain of G was from negative 2 to positive 2. Now, what do those have in common? You want me to answer. I want you to answer. Stalemate, okay? What do those have in common? Yes, anything from 0 to plus 2. You've narrowed it down because you have to be in this domain, which is everything greater than 0, but you also have to be in this domain, which is between minus 2 and 2. So that gives you just this part in the middle where you have LSU colors, okay? Purple and orange. They're not orange, okay. They say they're not anyway. Okay, so that's what right now we would say the domain of this is. Just any operation, adding, subtracting, or multiplying, you would be limited to that domain from 0 to 2. But this is division. What other thing comes into play in division? Square roots. What's inside the house has to be greater than or equal to 0. When you divide by a variable, what does that limit you? The denominator, what can you never divide by? Say again? 0. Okay? So now we have another restriction on this thing. It has to be between those two, but now it can't be equal to 0. Now what would make that 0? That denominator 0? Say again? No, if x is 0, that's okay. You have square root of 4. Say again? 2. Either plus 2 or minus 2. We already threw minus 2 out, so now you have to throw out the plus 2. Because you can't have that denominator being 0. So now your domain is, for this answer here, this is your answer, but your domain here is from 0 to 2, but the 2 is a parentheses, it's less than 2, not less than or equal to 2. You see why? Yeah. You have a question?
You got to solve for x anywhere?
No, there's no solving here. It's just saying identify, or, what was the thing? It said find the quotient function. And we found the quotient function, but then this tells us where we have to limit that function. What part of the domain? It has to be within F, within G, but then G can also not be 0. So you have to make it. So see, before we said this thing was less than or equal to 0. Now we have to say less than 0. I mean greater than 0. Okay? So we have to make that not greater than or equal to, but greater than. And that eliminated the 2. Because when x equals 2, that made it equal to 0. Can't divide by 0. So this part is pretty easy. The domain takes a little bit of thought. Okay? And generally you need to, unless it's obviously all real numbers, you need to specify domains. Okay. Now the second part of this problem, stay in purple, is asking for G divided by F of X. Guess what that would be? The definition is G of X divided by F of X. It's just what it appears. And what's your G of X? What's the g of x? Okay, the square root of 4 minus x squared divided by f of x, and what's that? The square root of x. Okay? And certainly you have to have that same limitation on the domain that we had from the two functions, which is 0 to positive 2, because those are the two functions we're dealing with. You have to do that if you're adding, subtracting, or multiplying also. But with division, what other restriction do we have? Same as last time. What can you never do? Second? You can't divide by 0. What would make that denominator 0? X equals 0. Before we allowed 0 in there, now we can't. But now 2 is perfectly fine. It's a real rational number. So our domain here is from open parentheses 0 to 2, but you can bracket the 2. Because perfectly okay to divide by square root of 2. It's messy, but you can do it. But you can't divide by 0. So that's what happens in your division. The domain is limited by whatever limits of those are. It has to be things in common. But you have one additional limitation. Your denominators cannot be 0. In this case, it eliminated the 2 up here and the 0 down here. The 2 came back into play. Does that make sense? Okay. And I think, yeah, it took them a while to get there, but they got it. The answer to the question here is the quotient function for f of g, f divided by g. Here's the quotient function for g divided by f, but you have to also specify limitations on domains, and for this case, you had limitation on both numerator and denominator. You get what's in common there, but then the denominator also eliminates the 2 here and the 0 there. All right, good deal. Any questions? All right, we finally move to the next slide. Well, these are the things from example 1. All right, composition of functions. Now, my guess is you probably could have pretty much added, subtracted, and multiplied, and even divided functions with no problems. A little bit of worry with domains, but you just do it. You add them, you subtract them, you multiply them, or divide them, okay? And sometimes there's nothing you can do to simplify like we just saw. That's perfectly fine to leave it in those forms. Have any of you ever composed functions before? Okay. This may be somewhat new, okay? Another way of combining functions is to form what they call the composition of one with the other. For instance, if f of x is a good old squaring function, x squared, and g of x is a linear function, x plus 1, then the composition of f with g, okay? The composition of f with g is defined as f of g of x, okay? And that's how you write it, okay? F of g of x. That's the composition of f with g. And guess what you do? You plug in inside first and work your way out. So you put in what g of x is, that's the x plus 1. So f of x plus 1. Now we operate on this with the f function. What does the f function do? Takes whatever's here and squares it. Very good. Well, now you've got an x plus 1 there, so you take the x plus 1 and square it. That's the composition of f with g. That composition is denoted by f and this little circle. It sort of makes it look like it's in a fog, doesn't it? Well, no, I mean, that's not what it's meaning. It's f composed with g, okay? That's how you read it, f composed with g. Now, and what does this mean? This means f, and I like to think of that as a O for off, f of g of x. That's exactly what this means next, okay? I'm pointing with my fingers. People at home can't hear this. This means that. Okay? When you see composition, you can then write it down like this. Any questions on that? Have y'all done this before? Not? Okay, so this may be a little on the new side. So here's your definition of your composition of two functions. The composition of function f with the function g is f composed with g of x would be f of g of x. Okay? That's how you do it. When you see that thing, think f of g of x. Rewrite it like that. And then I think it's pretty clear. Now, guess what? Domains are where you have to sort of do a little bit of thinking. Okay? Your domain for the g are all the acceptable values for x. Now, if we go back to that previous example we had, g of x was x plus 1. What's the domain of that? All real numbers. Very good. Okay? And then what's its range? All real numbers. Okay. So, why did I ask about range? Well, because g of x produces, for any x you put in there, you get to choose from all real numbers, it produces some other thing that's all real numbers. And then f was the squaring function, x squared. What's its domain? All real numbers. So yeah, you're perfectly fine. So, the domain of f of g is a set of all the x's in the domain of g, such that g of x, the output for g, the range of g, is then becomes the domain for f. Okay? And that's what you got. So here's how we picture that in our, what do they call this? Mapping things. Here you have the domain of g, that's your x. Okay? All the values of x which make g legitimate. Then when you operate on these x's with g, you get answers which are in the range of g, which is g of x. Okay? Then that becomes the domain for f. So f operates on the answers you got from g. The output from g operates on that, and that gives you f of g of x. Whereas the composition function starts with the x here and goes straight to there. Okay? To me, that's not completely enlightening, but when I understand it, it makes sense. Okay? I'm not sure it helps me understand, but now that I understand it, it does make sense. So let's do a couple. Okay? Here's your f, and there's your g. So what is f composed with g of x? What's that definition? I suggest you do this every time. How is that defined? F of g of x. Okay. Now, we're going to time out for just a moment here. Both of these are polynomial functions. Domains are all real numbers. In a little bit, we'll have to worry a little bit with g because its range is not all real numbers, but we don't usually worry about it, but just have to acknowledge it. So what do we do next? You plug in the innermost function. So leave the f on the outside. What was your g of x? 4 minus x squared. Okay? Now we take the f function, and what does the f function do? Takes whatever you put in and adds 2 to it. So what are we going to do here? Takes whatever you put in, which is, what's your input here? 4 minus x squared, and you add 2 to it. Yeah, you plug in for your x here, rather than x, you put 4 minus x squared. So you put 4 minus x squared, and then add 2 to it. That's what the f function says you do. You take what's here and add 2 to it. What's here now is 4 minus x squared, add 2 to it. Now simplify that, and what do you have? A little louder? Okay, negative x squared plus 6. Okay, if you want to turn it around, you can certainly do that. 6 minus x squared would be just as good. Okay? Good. Now, can you do G composed with F? What would be the definition of that? G composed with F. What would be that definition? Make a guess. Okay, wait. Write down what that means. That means G of F of X. I like to write that down first, and then it makes every step clearer. Where do we start? The innermost, the F. So leave the G alone for now. And what's your F of X? X plus 2. Now what does G tell you to do to what's inside? Okay, you start with a 4. Minus parentheses x plus 2 squared. Yeah, you take what's in here, you write down 4 minus what's in here squared. Well, here, what's in here is that, so it's 4 minus this thing squared. Okay, we got a little bit of work to do. It's not too bad, but let's do it. What does this become? Leave the 4 alone. 4 minus, let's square that first. Can you do it in one step, or do you need to write it out? X squared, I like that. Okay. Okay, plus 2x. Plus another 2x would be plus 4x plus 4. Yeah. Don't just square the pieces, you have to square the entire thing. Here's the rule. Either write it out, and I can tell you're mentally writing it out. X plus 2 times x plus 2, fall x squared plus 2x plus 2x plus 4x plus 4. Yeah, I could hear the teeth grinding in there, okay? So, that's how you, now, here's how, if you want to do one step, kind of, square the first, x squared, twice the product of the 2, that's your innards and your outwards, okay, they're the same. Twice the product of 2, the product is 2x, double that, you get 4x, then square the last. Okay? Now you can clear parentheses, and what does that give you? 4 minus x squared minus 4x minus 4, and what does that give you? All right, minus x, I can't write, x squared minus 4x. Perfect. Okay. Just a little bit of time out here. Notice here that f of g is in general not the same as g of f. In general, not. We will run into some special cases where they are, but most of the time they're not. And let me clean this up for posterity so people who are reading this will not be confused with what that number is. Okay, now the C part says, what is g of f of negative 2? How would we do that? G of f of x was this thing. So guess what g of f of negative 2 would be? Yes? Okay. You certainly could do that if you wanted to, and I can tell you're a hard worker, and hard workers can do math pretty well. It's the lazy people that really I'm looking for, okay? What's the better way? Just plug it in. Good old Glade, you know? Okay. Plug in the minus 2 of what g of f of x. You've already done all that work. Don't redo it. Just plug in what you already have. So what would that be? Minus a minus 2 squared minus 4 times negative 2. Very good. And what would that be? A minus, what's negative 2 squared? 4. What's minus times minus? Plus, no, you're multiplying. I'm sorry? 8. And what does that equal? 4. Very good. Now, this may have been what you were asking, but I didn't gather it to be. But let's do it this way. Let's do, and this may be exactly what you're meaning, g of f of negative 2. Is that what you were suggesting? Okay. Let's do that. Let's do what f of negative 2 is. What would that be? Say again? Okay. Y'all going to have to show me how you got that. Okay. I'm a little slow this morning. I didn't have much sleep last night. My wife flew in from Austin, and I had to pick her up at the airport at 11:30. So it was after midnight before we got to bed. All right, f of minus 2 would be? Plug it in, plug it in. It would be 0, because negative 2 plus 2 is 0. Now we're doing g of the output of this, which is 0. And what's g of 0? G of 0 would be 4. And isn't that what we got here? All right. So yeah, you could have done it 2 ways. And I thought you were saying carry it through all these steps again. But I got to thinking, no, maybe that's what you meant. And that would be I think that's actually easier. Just about as easy as plugging in. You have to plug in twice, but it's simpler numbers. Because it came out 0, it came out really easy. All right. Let's see how they did it. Okay? Can I erase this, or y'all need it a little longer? Zip it? No, that's not what I'm telling you to do. Okay. All right. Let's start with the first one. The composition of f with g is f composed with g of x is defined to be f of g of x. So what you do first, plug in the innermost, and that would be f of 4 minus x squared. So you go back to the f function and it says, whatever is in here, add 2 to it. So we take the 4 minus x squared and add 2 to it, and that gives you minus x squared plus 6. Y'all must have been looking at the book when you gave me the answer. I would have said 6 minus x squared, but now I see what you're doing. Okay. Now, composition of g with f, g composed with f of x would be, the definition is g of f of x. So write it that way. I think that's usually the best way to start. And then we will plug in what f of x is, g of x plus 2. And then the g function says, start with 4, subtract that thing squared. And that's exactly what we do. And then we multiply that out. They call it expanding it, but I say it's squaring a binomial. Okay, and then you distribute the minus sign across the parentheses and simplify, and you get minus x squared minus 4x. And it says, note that in this case, and I will add, in most cases, f of g is not equal to g of f. Nowhere close. But a few cases it will be, and those are special. And we'll see those coming up a little bit later. All right, then using the result of part B, plug it in, and that gives you negative 4 plus 8, which is 4. And then Elena was suggesting go back to the original and plug it in there, and you got the same answer. Now, they didn't show you that. Okay? Now, in that example, it says, and by the way, there is a checkpoint. I'd go home and or go to the library or go somewhere as soon as you can, work on those, make sure you got that down. you form the composition of two given functions. In calculus, it's also important to be able to identify two functions that make up a given composite function. Okay? You know, they're skipping down. They skipped example 6, didn't they? So let's pause here and go back and do example 6 before we do this slide here. Okay, so let's go back, here. And let's do example 6. How are we doing on time? 8 minutes, okay, that's good. All right. Find the domain of f of g of x for this function. Okay, here's f composed with g of x for the functions f of x is equal to x squared minus 9, and g of x is equal to the square root of 9 minus x squared. Okay? Now, they didn't actually say find that composition, but they do it, so let's do it. How is that defined? You tell me. That's a good place to always begin. That is what's that definition? F of g of x. That's good. It's pretty simple. And what does that tell you to do first? Don't look up here. Look over here. Be f of the square root of 9 minus x squared. Now, I've realized I just did something I told you you probably shouldn't do, and I did it because we're running out of time. What's the domain of this function? All real numbers. That's a good old polynomial. How about that? That's one of our issues again. And what's the restriction there? What's the restriction on G? What's inside there has to be non-negative, okay? So that means that 9 minus x squared has to be greater than or equal to 0. Now, doesn't that look enough like the one we did just a little while ago? What would you guess this domain would be? From before it was 4 minus x squared, and it came out between minus 2 and plus 2, right? This one would be between minus 3 and plus 3. Okay? And here's, I took you through the gory process before. If you want to know how I cheat, here's how I cheat, okay? Let's spell the zeros first. When is 9 minus x squared equal to 0? When x is equal to 3 plus or minus 3. So that's going to be the outside part, or that's going to be something that's important there. That's going to be where it's equal to 0. So either these bars are going to go this way or that way, one or the other. So do we want what's outside there or inside there? Well, let's pick an x. Well, first pick one that's outside there, like 4 or negative 4. What happens if you do that here? What's 4 squared? 16. Is 9 minus 16 greater than 0? 9. No, it's negative. So throw out the 4. So we want to look inside. Well, let's just check that. Pick something between minus 3 and 3. 0? Oh, good choice. Okay. Now, if you plug in a 0, what do you get? 9. Is 9 greater than or equal to 0? Yes, it is. So we want the things in between there, okay? That's sort of the quick way to do it. It's not the elegant way, but it's quick, okay? So the domain there is between -3 and 3. All right, let's go back to it. All right. Now, continue. What's f of square root of 9 minus x squared? What would that be? Your f function is right here. So what we're going to do, silence. Okay. What do we do? The f function says whatever is in here, what do you do to it? You square it and subtract 9 from it, right? Right? That's what you do to the x. You square it and subtract 9. So whatever's in here now, that replaces the x, so you do what? Square root of 9 minus x squared, that's what's in there. And what do we do to it? Square it and subtract 9. Right? Okay. Now, what is the square of a square root? One undoes the other. Yeah, they think of them as canceling out. It does away with that. So that gives you 9 minus x squared minus 9. And what does that give you? A negative x squared. All right. I feel like a dentist. Okay, but we got it. That's what f of g of x is, the composition of f of g. Now, what it said, though, we did it, but what it says is what is the domain of this? Well, guess what? You start with the domain of g, and the domain of g was from -3 to 3. Okay? Then you operate on that, and that's going to give you, when you start with that, you're going to get something that is a positive number, because g, this is the principal square root, it's a positive number, and it's going to be something that's in between there. So your domain of this, you're still limited by plus or minus 3. Even though looking at that, you would say that's all real numbers, but because up here x had to be here, the x still has to be between -3 and 3. You can't expand it once, because it was limited there, it's still limited here. So your answer, F, is going to be something less than -9, between 0 and -9. -9 and 0. Okay. They didn't ask for that part. Okay. So your domain is still -3 to 3. All right. Now, do we have time for this? Huh? We're out of time? Huh? Oh, how did you work it out so perfectly? Okay. So, we're going to start next time with the verbiage in the middle of page 79. Okay? Actually, that's where I started a previous class, too. But let me give you some homework exercise. I don't want you getting out of here without homework. I mean, this is the weekend. You got to have something to do, right? Do number 3, any of the odds 5 through 11, any of the odds 13 through 23, do 25, do either 27 or 29 or both, either 31 or 33 or both, and do any of the odds 35 to 41. And I think that, oh wait, no, you might be able to do 43 or 45 or both. And we'll stop there and pick up the rest. Have a good weekend working on math, right? That'll make it good, okay? Work on those quizzes, too. All right, good.